Alright, so we have a new really important idea in this section, and that's called the fundamental counting principle. And yes, it's about counting. It's not as trivial as it sounds, though. You've seen it before if you've worked on MathsMate sheets with me. Here's an example to illustrate how it works. Let's say we're trying to figure out how many license plates it's possible to make that consist of 3 digits, or 3 numbers, and 2 letters, if we can't have any repeats. Okay, so maybe the most obvious way to do this would be to make a list of all of the possibilities, but this is going to take you forever. You can start out with the 3 smallest numbers, 0, 1, 2, and the 2 first letters, AB, and keep going systematically from there, 0, 1, 3, AB, 0, 1, 4, AB, but this is going to take forever. Another way to do it would be to make a tree diagram, where the first set of branchings correspond to the number of possibilities for the first digit. And there are 10. There are 10 branches, 0 through 9. And from each of those, there would have to be, 9 branches for the second level of branching, corresponding to the 9 digits that would be left over. Not 10, because we've already used one. But this diagram is going to become ridiculously complicated very quickly. So the fundamental counting principle just says, look, for the first digit, we have 10 choices. Then for the second, we have 9. And for the third, 8. Right? And the number's going down like that because once we choose one, we can't repeat it. So if we choose 2 and 3, then we can choose any other digits besides 2 and 3 for that third number. And then the alphabet has 26 letters, so we have 26 choices for our first letter, and in order not to repeat, we have 25 for the last letter. So the fundamental counting principle says, look, the number of ways you can do this is just the product of all of these numbers, 10 times 9 times 8 times 26 times 25. That turns out to be 468,000. Right, this is really useful. And a way to sum up the fundamental counting principle would be like this. The number of ways for a compound event to occur is equal to the product of the number of ways for each separate event within this compound event to occur. So what I mean is this was a compound event because we chose three numbers and 2 letters. That's 5 sort of events within this one compound event of making a license plate. And to find the number of license plates, the number of these compound events, we just found out the number of ways that each of the individual events, the choice of each number and the choice of each letter, the number of ways that each of those could have been fulfilled, and we multiplied that all out. All right, let's look at another example of using the fundamental counting principle. What if we have to do as in example 4 on page 632 of your book and figure out how many passwords we could have for some computer system? Whoever's doing this has decided that the letter O and the number 0 are confusing because they look similar, and so they've decided not to use the letter O or the number 0, but that repeats are okay. And finally, they're going to choose 2 letters and 4 digits. Right? So the fundamental counting principle, well, we have how many choices for our first letter? Well, any letter will do except for O, so that's 25. And the second letter, well, we can repeat, so we still have 25 choices for the second letter. And for each of the 4 digits we're going to choose, we can repeat, but we just can't use 0, so we have 9 for each of those. So the answer is 25 times 25 times 9 times 9 times 9 times 9, which is 4,100,625. For homework, please complete page 633, 9 to 45 odd.